Here we take a look at the accumulator exercise. This is an individual assignment. Here we're going to calculate the total volume of fluid needed to perform all four actions listed above. The actions are close the pipe ram, open the HCR, open the pipe ram, close the HCR. If we'll follow the Bessey requirements, we must multiply the values we need, the volumes, by 1.5 times. To get the pre-charge pressure, we're going to watch the video that's called Accumulator Exercise. It's stored under week 10. When the bottles are charged up with the Kumi unit, the pressure will rise rapidly to the pre-charge pressure, at which point it will rise very slowly to the manifold pressure. To get the total volume of the bottles, we're going to look at the volume of one bottle and multiply it by the number of bottles we have in our system. The system for this exercise at the PERT lab has 10 total bottles. Now that we have the pre-charge pressure of 1000 psi and then the minimum pressure of 1200 psi by law, we'll use the ideal gas law to determine the difference in nitrogen volume between these two pressures. What does this volume represent? This represents an unusable volume, and it's unusable by law. If we were on the rig in a situation where we needed to make an adjustment and our pressure had fallen to 1200 psi, we would still make that actuation. However, this is a safety factor. Should we use gauge or absolute values in the gas law? We should use the absolute values. However, it won't make a practical difference in our case because the numbers are large and somewhat imprecise. And all of your calculations will assume that the total volume in a bottle is 10 gallons. Here we want to calculate the usable fluid. First, we'll calculate how much fluid we have when the system is charged to 3,000 pounds. Then we'll calculate how much fluid is left when we're at 1,200 pounds. That's our minimum. We'll subtract the fluid at 3,000 from the fluid at 1,200. That fluid that's left is our usable fluid. An example for this is in video 2. Here you want to compare how much you calculated as your usable fluid with how much from number 1 fluid you think you will need. Then let us know, is this enough fluid? Here it asks us to perform the 4 functions that we listed before the exercise. Close the pipe ram, open the HCR, open the pipe ram, close the HCR. After each step, record the pressure. We can use the pressure to calculate the volume in each step. So at the beginning, when we have 3,000 psi, we can calculate the total hydraulic volume in the system is 100 times 1015, that's the pre-charge, plus 15, rounded off 14.7 psi, divided by 3015, that's the pressure, plus 14.7 psi rounded off, times 100. Then that value, 33.66, subtracted, that's the nitrogen volume, subtract that from 100 gallons total, it leaves us 66.34 gallons of hydraulic fluid. After we perform the function, the pressure drops to 2680. Now again we'll calculate the nitrogen volume. That's 1015, that's pre-charge plus atmosphere, divided by 2695. That's the 2680 plus atmosphere. When we divide 1015 by 2695, we get, and multiply it by 100, we get 37.66 gallons of nitrogen. When we subtract that from the 100 gallons total, we're left with 62.33 gallons of hydraulic fluid after the actuation. When we subtract 66.34, that's the volume of hydraulic fluid before the actuation, from 62.33, the volume after the actuation, we get a calculated volume based on our pressures of 4.01 gallons. That compares with the book's expectation of 3.6 gallons. You can do this for each one of the functions. Assumptions and possible errors. If this is not what you expected from your calculations, closing, opening volumes calculated are different than what's listed, what are the possible causes? Some ideas can be the pressure gauge may not be accurate. It may be very hard to read the pressure gauge. The values could be different than what the book says. We might have read the book incorrectly. Do you have any other possible reasons for possible errors?